The 360 on Energy and Carbon, hosted by 360 Energy. Jeremy Keller, PE, is the VP of Market Development for Rondo Energy. Rondo Energy has developed a thermal battery which cost-effectively reduces the carbon intensity of industrial thermal processes using low-cost intermittent renewable energy. Prior to Rondo, Jeremy spent 10 years with Ameresco, developing and delivering energy efficiency and renewable energy projects for commercial and industrial facilities, with a focus on water, wastewater, food processing, and RNG projects. He is a licensed mechanical engineer in the state of Washington and has an MBA from Oregon State University. Now let's get into the episode with Jeremy.
Lysandra, it's a pleasure to be back, and I'm sorry our colleague from the UK, John Pooley, is going to miss this great episode. I know he's going to listen to it. He said he was quite anxious to hear it afterwards.
So John, if you're in your car and you're listening to us, welcome to the episode. And today we're joined by Jeremy Keller, VP of Market Development at Rondo Energy. Welcome, Jeremy.
Thank you. Thanks for having me today.
Jeremy, it's, as Lysandra said prior to us starting, I've been excited about this session for a while. By the way, we have speakers all around the world, so I'm always excited about, but yours especially, because I think the product offering is quite unique, even though we'll get into it. Listen, how I got hold or understood about your organization is I watched the TED Talk by your CEO, John O'Donnell, and I just caught my attention just because I think the product that you're offering, there's possibly a really great opportunity going forward. So we're going to get into that. So I'm always fascinated with organizations and what makes them tick and who they are. So can you explain who Rondo Energy is, what the ownership structure? Can you just kind of share with our audience sort of sense of who you are and what makes you tick? What keeps you going?
Yeah, Rondo Energy is a company that was founded really with a target of decarbonizing industrial process heat. So it's a pretty traditional venture capital backed startup story. So started the organization with the co-founders, slowly built the team, found some product market fit, raised a Series A, raised additional money since then. So to date, Rondo has raised 80 million. Sorry, I always have to remember back where we are. And we have investors like Bill Gates, Breakthrough Energy Ventures, Energy Impact Partners, who represent their investors are all of the electric utilities kind of across North America and globally. And then we have a bunch of strategic investors like Microsoft and Rio Tinto, SCG, Titan Cement, Saudi Aramco, and SABIC. And I'm forgetting one. Somebody's going to get me in trouble. There's one more. But so that's kind of the funding and the ownership structure. Yeah, we're really focused on that industrial process, heat market, and decarbonization. And it came out of the co-founders. You mentioned John O'Donnell, our CEO. Their background previously had been in solar thermal. So this is John's fourth or fifth startup, really focused on the energy space. And he did 2 or 3 solar thermal startups before. And unfortunately for them, solar PV got really, really cheap, really, really fast. And so that kind of led to this idea of industry needs zero carbon heat delivered 24/7. And how do you store that intermittent renewable energy from wind or solar? And how do you deliver that as a solution to repower industry and decarbonize it cost effectively?
So the companies, by the way, those are heavy hitters that you're talking about backing behind you. Names are quite familiar for, I imagine, our listeners. So the co-founders, is it John and the parties that you mentioned, or is there other co-founders that are involved in this? Like, is it a small group of co-founders with support from other people?
Yeah, the co-founders were John and Pete Von Buren. So the two of them had worked previously at Glass Point Solar.
Okay.
And then from that, they actually built a team, and I was hire number 6. But a bunch of the folks that were at Glass Point before came and joined them, and kind of, they understood the problem space of what industry needed. And instead of attacking it with solar thermal, we pivoted to this solution with using electricity and storing it as thermal storage and as high temperature heat. And so
fair enough. And I think our listeners are going to hear that actually renewable energy is a big part of this whole type of technology behind it as well.
It is. And as we get more and more into it, we actually see it's kind of a circular beneficial relationship where, a heat battery or thermal energy storage really benefits from how large utility scale renewables have gotten and how cheap they've gotten. But at the same time, adding heat batteries to the grid to decarbonize industry means that you can integrate even more renewables onto the grid. And even though you're adding massive new loads, you're enabling the grid to get cleaner faster, which is a little bit funny and paradoxical thinking, but there's a lot of these circular benefits of kind of electrifying these big, huge industrial loads.
You raise a really good point. I know we're going to get into this, but often people in the electrical industry, because of traditional ways, renewable energy, because it's intermittent, is seen as being problematic because it's intermittent and loads people don't always operate. So we'll dig into this because that's actually a fascinating point that we'll actually engage and create more renewables, which will make it even more cheaper for renewables as we go forward. Okay, so let's just, if we could, and maybe we touched about it, but can you explain the Rondo heat battery technology? How does it work? Let's start with that if we could.
Our CEO came up with a really fantastic, simple analogy that I thought was a little hokey at first, but people really gravitated to it. So like the simplest thing to really visualize is if you took a brick, just a normal clay brick that your house might be out of, and you stuck that in your oven and you had an electric oven and you heated that brick up. That's what our heat battery is, but just really big and really heavy. So we're using clay bricks. It's a very standard clay. This clay has been used for heat storage in the steel industry for 200 years. It's widely available, no rare earth metals, really just kind of comes out of the ground, just dug up. We cast that into bricks. We stack those bricks up into a tall structure, and then we heat those bricks with electric resistance heaters. And those electric resistance heaters are more or less the same heating element that's in your toaster, just in industrial size shape. And those show up on a spool from suppliers. So everything we're doing is really utilizing tried and true existing materials from industry. And so we take those bricks, we heat them up. We heat them up to 1100 to 1500 degrees Celsius, 2000, 3000 degrees Fahrenheit. So the brick is storing that heat. And then we'll blow air across those bricks. The air gets hot, and then that air flows across a boiler. So you utilize the same existing boiler that's used in like a combined heat and power gas turbine facility or in a combined cycle power plant. And we buy those boilers from those same manufacturers. It's called a heat recovery steam generator, or some people call it a HRSG, the acronym there. And that then delivers steam to the industrial plant to replace an existing boiler. And that steam is delivered at the same pressure and conditions as that existing facility operates at. So it's really a drop-in solution, and it can fully replace that gas boiler. So that's kind of the simplicity of it. Those bricks and those heaters are all inside of high temperature refractory insulation. There's additional insulation layers. And so it's really efficient. So folks have a hard time with this one, but for every 100 megawatt hours in, we deliver 98 megawatt hours out as heat. So it's like a 98% efficient, which folks are like, that's way too efficient. But an electric boiler is effectively 100% efficient. And so we have a little bit of shell loss, energy loss through the exterior of the system, but otherwise it's, just extremely efficient.
Can I dig into the actual, is there some unique qualities about the brick besides clay? Do you have to add any other ingredients to allow it to go to that temperature and to and like my understanding, this is a 30-year, if not longer, lifespan of the product. Is that correct?
Yeah. The asset life, we typically describe it as a 40-year, 40 asset life. The short answer is no. So the co-founders really focused on going after a solution that would be commercialized and bankable as quickly as possible. So there's a lot of folks doing something, similar types of solutions, but they're using really interesting materials, really cool materials. And the co-founders really focused instead on using this existing clay. It's a high alumina, high silica clay. So it's formulated to have a little bit better heat transfer than like a brick that might be for use for insulation, but it's really off the shelf. It shows up in super sacks. We order it from 5 or 6 different global suppliers. And that's really done intentionally because, it has 200 years of experience in industry, in heat storage at higher temperatures than we're using it with more cycles per day. And so you have this really well understood material of how it's going to perform in industry over a 40-year life.
Excellent. And can you share with us what industries that you're targeting? Like, is it low temperature, high temperature? Can you share with us where you're going?
Yeah. With the temperatures that we can deliver, we can really serve industry, almost every industry. There's a couple of spots like, the direct iron reduction process in, iron ore is not something we're going after, mainly because they're solving that with some other ways, either electrochemistry or hydrogen. And that's more of a chemical reaction. There's some really high temperature calcination reactions that are a little bit harder to fully solve, but a heat battery is still like a 50 or 75% decarbonization strategy based off where we are today. And then, there's plans to be 100%. So it's actually a little bit of a hard answer. I will say though, from a commercial point of view, so there's like the technical answer, which is like we can serve like 95% of industry today based off energy consumption, and CO2 emissions track that pretty well. From a commercial point of view, which is where I spend more of my time, early on, we really love going after facilities in industry that use steam, any steam pressure or temperature condition, hot water, people using heating oil, even if some industry uses like CO2 as a heat transfer fluid. We can also, instead of delivering steam or hot water, we can deliver just hot air. But we really like those steam and hot water applications because we can deliver the heat battery, tie in right to the existing boiler plant, right into the existing steam headers, pipes. And in a lot of cases, there's no plant downtime. We can do all of the integration and commissioning and startup and then tie in, and there's a switchover. You keep your existing assets. During that period, you operate in parallel, and eventually you phase the fossil fuels out as you get comfortable with the system operating fully and completely. But we really like that because there's no downstream process change and no impact on facility operations, other than once we come online, we've reduced your carbon emissions 90 to 100%.
Which is extremely attractive for certain industries that have demands by certain clientele that is asking for that type of thing. So question on the product, is it commercially viable? Is it being sold now as a commercially viable product at this time?
It is. And we have a commercial pilot facility that's been operating for 13 months right now. It's at an ethanol plant in California. And that system has been delivering heat into their process, replacing natural gas that they would otherwise combust. And that commercial pilot is built out of our full size bricks and our full scale heaters, full voltage heaters. And then we have projects that are coming that are the kind of full size product. There's a couple of gigawatt hour pipeline of those projects right now between construction and engineering and permitting and all of that. So we're delivering commercial systems to facilities kind of globally. I would love to give more examples, but we haven't announced any of them. So my marketing guy would get grumpy with me if I got ahead of them.
Fair enough. And you probably have some NDAs in place as well, so you have to be careful. Understand. Last part of this piece that I wanted to ask you. So as you mentioned, this technology's been around for a couple hundred years. It's actually fascinating how everyone thinks it's got to be all this brand new technology, and and a lot of this stuff has been done. It just has to be modified and thought a little differently in its application. So what are you doing to enable the technology to be more effective than what it has been in the past? Can you share with our audience what that is?
Yeah. I mean, historically in the steel industry, they used these ceramic bricks to capture the waste heat from the combustion process. And so they had hot combustion gas, which is a mix of CO2 and sulfur and all of that, flowing through the bricks, and they heated the bricks up with hot air. And then they had a second stack of bricks that was already hot from before, and they would blow combustion air through it and recover that heat, and then they would cycle every hour or so. So the major change that happened with what enabled us to go do what we're doing today is that instead of heating it with waste heat from the combustion gases, we're heating it electrically. And 5 years ago, that kind of would have been idiotic because renewable electricity was really expensive and electricity was really expensive. And, the solar has declined in cost 90% in the last 10 years. Wind is very similar, right? So wind and solar have made electricity really, really cheap. And then when you look at your wholesale electricity markets, when you have a whole bunch of wind and a whole bunch of solar on the grid all at the same time, when you kind of hit like this 40% mark, you get these prices on the wholesale market where the middle of the day often is going to like zero and negative. And so all of a sudden the price of electricity on the wholesale market is cheaper than natural gas. And so that's really what's driven this idea of taking these simple ceramic bricks, heating them electrically, is because electricity has gotten really cheap. And it's now kind of the cheapest source of energy in large parts of the globe.
Right.
And especially if you're taking into account and I should go back and I didn't give a very good answer on like what industries are we targeting, because to me it's just such a broad swath. But it's food processors, love food processors, pharmaceutical, general manufacturing if they have big steam loads, like we love that. Chemical refineries are huge. Mining and minerals processing, absolutely fantastic. Pulp and paper, a little strangely, but oil refineries, like petroleum processing, they have giant thermal loads that you can lower the carbon intensity of your petroleum fuel, which it sounds a little funny, but CO2 savings is CO2 savings. Feels like I'm missing some important industry, but that kind of gives a broad swath of.
It's a broad spectrum. Listen, we talked very briefly, and I didn't capture this, but we are exposed to the greenhouse sector here in Canada, especially in Southern Ontario, and they're big players. They use hot water. They don't use steam for heating. Is there an application? Like, is there a certain sweet spot of size boiler replacement that it fits for you guys?
Yeah. I'll answer a slightly different question, then I'll come back to that one.
Sure, please.
I think one of the things that I always like to point out to folks, even if they're in the energy space, they don't always do like the unit conversion. But when we think about like industrial heat loads, like a medium-sized pharmaceutical facility, it might have an electricity demand of a megawatt or 2 megawatts, 1,000 or 2,000 kilowatts. Regularly, kind of broadly across a lot of industry, their steam demand, if you convert it from pounds of steam per hour or million BTUs to megawatts, you put it equivalent with electricity units, is often 5 to 10 times bigger.
Yes.
Right. And so a pharmaceutical facility might have a 2 megawatt steam demand, and it might have a 10 or a 20 megawatt, or a 1 or 2 megawatt electricity demand, and it might have a 10 or a 20 megawatt steam demand.
Yes.
And so like that's kind of the scale of the opportunity. When we think about like a chemical refinery, that chemical refinery might have a 40 megawatt electricity demand, and its steam demand might be 200, 300 megawatts. And those facilities are typically operating 24/7, 360 days a year. And so they're just burning a ton of fuel, and it's high temperature, really intense, very energy intensive. And so that's kind of the scale of what it is that our heat batteries are going after. So back to your question about greenhouses, we've looked at a number of greenhouses, and they're really pretty interesting for their heat demand. Relative to other industry that I was just talking about, one of the things that distinguishes them is that they have a pretty seasonal heat load. And so we can be a solution for that, but you really want to find something to do with that heat battery and all of that infrastructure in the summer.
Yeah.
And so one of the wonderful things about our heat battery is because we're storing the temperature so hot, we can deliver really high pressure steam. So I've talked mostly about industrial process heat, but we also spend a lot of time looking at either retrofitting and refiring coal power plants or combined cycle power plants. So running utility scale steam turbines or building brand new ones and doing kind of power to power type systems. So more of like a traditional battery might. And so for like a greenhouse, depending on where we are, those are sometimes some of the applications that we look for, which is in the winter, delivering most of that energy out as steam to the greenhouse to meet its heating load, and then integrating some sort of a steam turbine into the system to be either delivering electricity to the greenhouses behind the meter or exporting back to the grid to provide grid services during the summer, helping meet peak summer loads, providing time matched electricity. Like those are all of the things that we really think about quite a bit.
Interesting.
You have a great website, by the way. And one thing that stood out to me is the statement Rondo will eliminate 15% of global CO2 emissions in 15 years. Could you elaborate on how Rondo plans to eliminate these emissions?
Yeah, I mean, it's a really ambitious goal. Like,
It is.
and it's funny because I throw around, a chemical refinery has a 200 megawatt steam demand. And when you think about 200 megawatts 24/7, just to power that on like an energy basis, you need to build something like 600 megawatts or 800 megawatts of solar. And, like that's going to be thousands of acres of new solar and wind. And I promise I'm coming back to your question. I'm taking the long way there. And one of the things, and we have a later question about this, but I'm just going to touch on it real quick. I mentioned earlier, we're 98% efficient. A lot of folks are thinking about doing these same things with hydrogen. But when you do renewable electricity to hydrogen, to compression and storage, to combustion, your round trip efficiency ends up being about 50%. So for any of these industrial facilities, you would have to build twice as much renewables. Okay, so back to the 15% of global CO2. Industry as an energy load is kind of 33, it's about a third of all industrial or of global energy demand. And, the emissions are actually a little bit higher than that, I think. And so the opportunity is really, globally 30% of emissions. And when you think about their energy consumption of that 30%, 3/4 of that is industrial process heat. So they're burning natural gas, they're burning propane. There's still a lot of coal being burned. And even more strange is there's a bunch of diesel being burned for steam. And so, targeting that giant untapped market where they just haven't had great solutions for decarbonizing it to date is how we scale it's kind of the target of opportunity and how we get to that 15% number. Now, how does Rondo get there? It really comes back to that core thing I talked about with the technology. We're using very simple materials that have plenty of existing mining capacity to deliver our solution, right? There's already 30 gigawatt hours of these bricks in use today for heat storage in the steel industry and in glass industry. And so by using really proven, widely available materials and technologies, we're able to scale rapidly. So today we have a manufacturing capacity of 2 gigawatt hours of heat batteries. And with our manufacturing partners, that easily scales to 90 gigawatt hours here in the next 3 or 4 years. And so that if you project that out over 15 years, we're able to really scale to meet the scale of the challenge. And utility scale renewable and wind has been scaling at that same rate. So it's definitely one of those hockey stick growths that every startup company likes to project, but really design the solution and the market and the fit such that it's achievable.
Okay, Jeremy, I'm going to ask you a question that you didn't know. So if I'm going to say it, and if it's not comfortable, just don't respond or just say, no, I can't answer that. The growth that you're talking about is huge. It's significant, right? How do you accommodate that production so quickly? Do you work with strategic partners to help make that happen? Has that been thought through how that's going to occur? Can you discuss that or address that?
Yeah. It really is a function of that material that was selected for the heat storage media. And when we think about scaling our production, to scale our brick manufacturing capacity, what we need to buy is more kilns for drying and curing the bricks.
That's right.
And those are, produced today on an industrial scale for ceramics and metals. And like there's a giant ecosystem of that already. And they're kind of a 12 to 18 month type lead time on that equipment side. But each kiln can deliver 3, 6, 9 gigawatt hours of our bricks, especially as you go to 24/7 operation. So that's really what allows us to scale it. The other piece of it is that, that the heater wire we're using is it's a really simple metal. And inside of the global metal industry, there's no real challenges on scaling that up either. There's no rare earths or anything like that. And then the other piece of our system is like a standard boiler. And people are producing gigawatts of boilers every year for the natural gas combined cycle power plant industry, for cogeneration turbines. And frankly, they're really excited to have some place for their boilers to go as the world electrifies and moves away from fossil fuels. So we're really, again, the founding principle is get to commercialize, get to bankable, be scalable such that you can meet the scale of this challenge.
Now, you've talked about the industries that you can deal with, but you also mentioned what is required, and that's excess renewable energy. So is there certain markets, like locations, that you're targeting based on that criteria?
Yeah. On one hand, it's really simple. And then on the other hand, it's complicated. So we love any market where we can get access to cheap intermittent electricity, which is a little funny. Like most people don't want intermittent electricity, but we love cheap intermittent electricity. And then we love markets where fossil fuels are expensive. And so that could either be because the fuel itself is expensive or because there's a regulatory or implied carbon price. And so we're kind of, if you're in the energy space, we're looking for like the reverse spark spread, right? And one of the things that enables us to do that is that, and we didn't talk about it yet, but it is a key enabling thing. And it's a differentiator actually for a lot of thermal storage compared to other technologies. With these electric resistance heaters, it's really cheap, I should say. Like the marginal cost for us to put more heaters in is very small. So we can charge really quickly. So a very typical, easy to run with numbers is we might charge in 6 or 8 hours every day, but deliver steam 24 hours a day. And that's a little weird if you're used to thinking about like lithium ion batteries, because we're charging and discharging at the same time. But by charging in 6 to 8 hours every day, one, you can capture when that sun is shining and when the wind's blowing, right? You can charge in the period that kind of matches what their shapes look like on production. But two, when you go and look at the wholesale markets, the price of electricity that you can capture if you're only buying the cheapest 6 or 8 hours every day is oftentimes 50% less than the average price that day. And in some cases, it's even lower. So we love geographies and we love regulatory environments where either there's a great renewable resource. California has great sun. The Midwest of the United States has great wind. Australia has great sun. Europe has great wind resources. It also has a ton of installed solar. But Europe is interesting more so. I mean, they kind of like not the best renewable resources, but culturally and regulatorily, they're quite a bit ahead of the rest of the world where they've committed to it. And the regulatory carbon price there is quite attractive. But beyond that, like culturally, when I talk to European industry, especially with the war in Ukraine and the volatility of gas prices, they're just all in on decarbonizing their industry. And so it's not a matter of like, it's not, am I competing against business as usual natural gas? It's what is the alternative that you would look at? So I love Europe. I love Canada because Canada has a strong carbon price. There's great renewable resources in parts of Canada. California is wonderful. Australia is awesome. Europe, yeah, Europe broadly. And, then globally past that, you start to get a little stretched thin as a company, but there's fantastic things happening in like Chile with their electricity prices and the amount of solar that they have in their solar resource. South Africa is a really interesting market as well. And there's not too many places in the world where it's not you where you can't find some great solution. Like we're looking at stuff like above the Arctic Circle, right?
Wow.
Like, so yeah, it's the geography is probably less of the criteria, and it's more about how much of renewables have been deployed, what is the state of fossil fuel prices, love locations where they're paying liquefied natural gas prices, LNG, and then the regulatory environment of like how do you access wholesale market prices.
Okay, so I think if the market's only going to get bigger because the people that are behind are sooner or later going to have to figure out they're going to have to do something on carbon
Well,
emissions,
and
right?
we actually see that, like, I love that. We have this giant tailwind pushing us forward, which is that wind and solar, even in today's high interest rate environments, are getting cheaper. And then as more wind and solar come on the grid, those wholesale prices continue to dip in those periods when the sun's shining and the wind's blowing, right? And so there's just this electricity prices are only getting better for us as you move forward. And so the geography where we can go after just keeps increasing.
What specific challenges does Rondo encounter in enabling this product to be mainstream?
Yeah. I mean, the simplest one is that any new product always has this new technology hurdle to get over. And I've talked about that enough. So I won't go on about how we've really designed our system to try and address that as quickly as possible. I think there's kind of two big specific challenges that are not unique to what Rondo is doing, but we're sometimes I feel like at the forefront of kind of just running into it. And then we're just a little bit ahead of some of the other solutions out there. When you think about wind and solar, they have this wonderful thing where once you've bought them and installed them, the electricity is kind of free, right? And so the cost of electricity from wind and solar is really just paying back that giant capital investment up front. Well, when you add our heat battery, we're kind of just an extension of that. And so one of the challenges is the same challenge that wind and solar have is it's a lot of capital to get deployed. And how do you financially and contractually line that up with everybody so that everybody's happy with that and that you can get risks assigned to the right people and get that price to be cheap and that sort of thing. So I think that's an interesting problem that decarbonizing industry has to face regardless of how you're going to do it. And I mentioned before, like if you're going to do hydrogen, you actually have to build twice as much renewables. And so your capital investment is twice as big, right? So that's an interesting one as we think about the commercial side of it. The other one that we're a little bit on the forefront of, and hydrogen folks are just starting to run into it, but other electrification solutions are kind of running into it as well, is electricity grids and electricity grid operators and tariff design and regulators have always kind of just assumed load. Electricity consumers want electricity available 99.99% of the time. They want really highly reliable electricity. You turn that motor on, electricity needs to be there to serve it. And so the tariff structures and the rate design and the way that you pay for electricity has really been designed around that core concept. And even wholesale market access has been designed around that core concept in that load is just a price taker. They're not actually they're not actually participating in the market. It's not a two-sided market. There's just a supply curve and there's no demand curve. Demand is it'll just take pay, whatever. Well, our heat batteries are actually quite a bit different than that. We're a load that doesn't want 99.9% reliable electricity. We're really comfortable with electricity that's only available 25, 30% of the time. And when I talk to utility folks and regulators, they look at me like I'm an alien when I say that. They just cannot comprehend that concept. And then like the next extension of that is like, we're load that can turn on really quickly and turn off really quickly. And we want to participate in a wholesale market. We want to submit a price and say, I'll buy electricity at $10 a megawatt hour, but I'm not going to buy it at $60 a megawatt hour. Right. And then like the next layer beyond that is is a similar thing to what a lot of the lithium ion batteries that are participating in utility wholesale markets are, is, and I'm getting into the weeds here, but there's like an opportunity cost too, right? Because we're storage, we want to buy the cheapest hours of the day. And I don't want to pay 20 right now if 3 hours from now I could pay 10, yeah. Right? And so my wider point is that a lot of barriers to entry are just the electricity grid and wholesale market hasn't been designed with the idea of load that is dispatchable and price responsive, or load that has storage integrated. And you see stuff out there that is a little bit close to what you want. ERCOT actually is probably some of the best, where you can do a controllable load resource and you can bid into the market directly, and they have really strong retail choice. But a lot of utilities will have a regulated off-peak tariff. But that off-peak tariff still charges you a demand charge that is based off your peak demand for the month, not your peak demand when the utility has its peak demand. And so there's this strong disincentive from that for you to not have really big loads, where what we want to do is we want to fill in the troughs. When the utility's load is low, we want to buy from them because electricity is cheap. We're going to utilize all of that transmission and distribution infrastructure a lot more. It's better for all of the utility buyers, because we're, helping them amortize all of that infrastructure over more electricity sales. But again, it's a little bit of an uphill conversation. And then with how bifurcated all of the markets are, you end up having that same conversation with, the United States, 1,400 different electric utilities.
Is it fair to say then, Jeremy, you prefer deregulated marketplaces versus regulated with your product?
Yes. Although even in that case, there's pretty big differences market to market.
Yes, there is. Yes.
And so you're every single time you're a little bit of okay, what are the rules here? And then how big of a lift is it to get them tweaked or modified to really accommodate us? But, Energy Impact Partner, a bunch of their investors are the electric utilities. We have really wonderful conversations with them, and they're excellent partners for us. And they're really bought into this value proposition of increasing the load on their system during off-peak hours, but helps them sell more megawatt hours without increasing their peak demand. So the vertically integrated utilities can also be great partners, because they kind of see this coming and see it as a solution to help them get to net zero and grow sales without increasing costs to the rate.
Well, on the flip side of challenges, could you provide an example of successful installations of Rondo's heat battery technology?
Yeah, the one that we're most public about is the Calgren Renewable Fuels commercial pilot. And, the thing that we love about that is that, one, they're just excellent hosts. And, when you're doing your first commercial pilot, you really need a special sort of customer that is, flexible and innovative and, forward leaning. And so they've just been a great host for us. One of the wonderful things about it is that we were able to completely install that project and tie it into their plant with zero downtime on their facility.
Oh, that's perfect.
To date, we've caused zero downtime for them, right? And so our system is very much adding heat to their facility, responding to their demands, shutting down when they might have a plant shut down for maintenance, that sort of thing. And that system is charging during California's belly of the duck. So we're always charging during the lowest carbon intensity period of the day. And then we're delivering heat to their facility 24/7. So I like to call it a baby heat battery. So it delivers 150 kilowatts. It charges at 450 kilowatts, and it stores 2 megawatt hours. And that system, those core bricks, we stack those taller and wider, and our full scale systems are more of 7 megawatts of heat delivery, 100 megawatt hours of storage, 20 megawatts of heat delivery, 300 megawatt hours of storage. Those are big numbers if you're used to thinking about lithium ion. Those are closer to utility scale systems, but that's the size that's required to really decarbonize that medium to large industry.
Jeremy, question on the model. Are you selling the equipment as equipment, or you also have an option where you become the utility that provide and sell heat? Can you share with our audience your model?
Yeah. Yeah. We're doing both. We're doing both right now. So a lot of industry really likes a capital light type model. And they really like the idea of what we would call heat as a service or storage as a service. And it's very similar to what you might have for like a renewable power purchase agreement, a PPA, where Rondo is responsible for funding, financing, and owning the heat battery and renewables, or however we're going to charge the heat battery. And then we sell them heat under a firm price contract. I say heat, but I mean steam or hot air or whatever, under a long-term firm price contract. And the things they like about that is that in a lot of locations, that's being delivered at less than business as usual. So cheaper than what they're paying for natural gas and any sort of carbon price. But then two, it really shields them from that volatility of the natural gas market.
Right.
And of the carbon market, right? They have a predictable firm price. We're seeing more and more of the CFOs and the financial side of the house really putting a value on that stable price and really understanding that there is value in being shielded from the volatility. On the flip side, though, a lot of our customers are pretty happy to deploy their own capital as well. And
Sure.
so we're delivering projects as turnkey installed systems. We're also working with EPC partners where we're an equipment supplier and they're the project delivery contractor. So we're really flexible about how we're going to market and really trying to meet our customers where they are. It's getting better, but for a long time, I've said that we really want to be a heat battery supplier. But today we're doing a lot of project origination and project delivery. And the reason for that is that the folks that have been traditionally in the gas boiler and gas cogeneration system, they understand the steam side of the house, but they have no idea what's been happening on the electricity side of like utility scale renewables or how to interact with the utility and the wholesale market and all the sophistication there. And then on the flip side, the folks that know all about electricity, large renewable developers, they don't know how to spell the word steam, right? And so we've been fitting in the middle of like really holding the hands of both sides, but the market's getting educated. So yeah, we're getting...
I would reinforce what you've just said, that typically clients, even within clients, you have people that will understand future pricing, gas or electricity, but they won't understand their usage. And there'll be people that are responsible for usage that don't actually understand pricing. So I actually completely understand why you're saying there's quite a learning curve associated with that. Yeah. But I do think what you've said is it's going to have to change. Energy is going to have to be more of a factor that people are going to have to deal with and not take for granted. And the ones that take it for granted will probably be disadvantaged because they'll probably end up paying more money than someone who actually knows what the heck they're doing. That's where I think this is going.
I want to echo that in that, as this electricity market moves into the future with just a lot more intermittent or variable production assets, there's a lot of opportunity for margin growth from industrial facilities that can treat their energy input as something that they're managing and building infrastructure to manage versus just a fixed cost that they just have to deal with. And right. Things we see is like, if you, for whatever reason, can configure your industrial facility to be able to shed your heat demand and your electricity demand 50% or whatever that is, it's the traditional demand response thing, but you take it to the next level in that you can get energy prices that are 25, 50% cheaper just by saying, yeah, okay, for 30 hours a year, I'm going to reduce my load substantially, right?
Yes.
And that's hard for a lot of processes. There's no way around that. But there's also things people can do where, like, in a lot of occasions, a silo holding work in process is some of the cheapest energy storage you can buy. I have not been very successful in that conversation with folks, though, to date. So I think there's going to be a lot more work needed on just kind of...
Talking about experience I've been doing for 25 years, and still we have a long way to go, just to be clear, just so you know.
Yeah, I mean, demand response has been trying to do very similar things for a long time, and it's tough. But the opportunity is increasing, right?
Agree. Totally agree. So last question for me is, when you look at sort of traditional fossil fuels, who do you actually see as your competitor? Is it fossil fuels? Is it hydrogen? Or is it even battery storage as seen as a competitor? So I'm kind of curious what the answer is for this.
Yeah. Traditional fossil fuels, business as usual, do nothing is the biggest competitor. And that's just always the case, like just momentum. So I'll put that one aside because it's not actually interesting to talk about. The competitors that we see are kind of spread all over the place. Most of industry loves to just be like, we're just going to do renewable natural gas. And then they go and get a quote for it. And they're like, oh my gosh. Like, renewable natural gas is 10, 20 times more expensive than fossil natural gas. And they're like, well, that's not going to work. So that's where people tend to start. We see a lot of folks like to explore going down like the biomass route. So burning wood, that can be pretty cheap. I will say that it's really dirty. You need a lot of space, and your air emissions are actually going to get worse, like from point source emissions. And then also just, folks start to get into like, what's the surety of supply and the amount of time and energy in maintaining that and making sure, you're getting 5 trucks of wood every day. And like, so some people will think about that if they're really in a location where that's just for whatever reason, it's easier, but the capital cost of that is pretty high and it's kind of a big pain in the neck. A lot of folks are looking at electric boilers. Electric boilers, tried and true technology. They can serve a lot of industrial process steam. They can't serve all of it right now. They're really relatively cheap from a capital cost point of view. They're pretty easy to operate and maintain, but their operating cost is substantially higher than what a heat battery would have because you're buying that around the clock electricity and you're having to pay all of those demand charges and transmission fees, and you're not able to shed it. And then like the electric utilities just can't really meet that demand, right? Like, there's folks that are waiting 6-7 years for a sub distribution station upgrade to add 7 megawatts of steam. And so electric boilers, just like, people kind of like them because they're simple, but the operating costs just kind of rule them out for a lot of folks. I love heat pumps. I was trying to do industrial heat pump projects for half a decade before I joined Rondo. And, they're coming a long way. There's a bunch of great startups in that space as well that are delivering heat pumps that can do steam. They're still limited quite a bit on what pressure they can deliver. People love heat pumps because their efficiency can be 200-300%. What we see though is that you either need to do some waste heat recovery, and that's like a bunch of custom engineering and it doesn't widely work at every facility, or it might hit your end use temperature, but your steam distribution is at a temperature that they can't serve. So now you have to repipe your entire plant. So you have major interruption in plant operations, and they're a little bit behind us on the commercialization curve. They're coming fast, so I'm not discounting them, but in general, the heat pumps, they're going to have their place. They're going to be a strong solution. I see though that they also still in a lot of jurisdictions have electricity price challenges, and that they again are having to pay all of the distribution demand charges and transmission fees. And so even though they're 200% efficient, they might be paying 4 or 5 times as much for electricity all in as what our heat battery would. And they're not going to be time matched with that renewable, right? That's kind of this future proofing thing that our heat batteries have, is that we're charging when the renewables are producing. I don't want to go too far into a rabbit hole here, but people today buy RECs, renewable energy certificates, where they're like, oh, I bought, my annual consumption is 1 million kilowatt hours. So I bought 1 million kilowatt hours of RECs. And they're like, we're renewable. But everybody's moving towards, no, your renewable electricity needs to be produced when you consume it.
Yes.
And our heat batteries are really future proof on that. And then the other ones, heat battery or heat pumps and electric boilers are probably what we see folks really exploring the most seriously. Some of the largest facilities are exploring CCS, carbon capture and storage.
Surely.
We see that that's just not very cost effective.
It's a long term. It's like 7 years to actually from regulatory to full.
And the CO2 pipelines are having the same, if not more, permitting challenges as utility scale renewables. So it's going to be the solution for some folks, but it's for small industry, small to medium industry, and I say small, I mean like your large food processor. Large industry is like a chemical refinery or a cement plant, right? Like for the small and medium to even large, CCS is just not really cost effective, or it's going to be really hard to make it work. And then lastly, hydrogen. I talked about the efficiency of hydrogen. I think that that's a big challenge. The economics of it are still pretty challenging from what we see, even with the United States and Canada's and Europe's, really generous incentives. It's first that hydrogen is first going to go to much more valuable applications,
Diesel
like
application, I think.
fuels, that sort of thing. But then second, like it's a tough economic puzzle to make the hydrogen work. And then you still have to retrofit your boilers quite a bit. And you're actually going to increase a lot of your NOx emissions. And so you probably have to increase your point source emissions savings or cleanup equipment as well. So like we don't really see too many people seriously considering hydrogen for general industrial process heat. There are gonna be some spots where it's the solution. Iron, steel, direct iron reduction. There's a big push to use hydrogen for that. And there's reasons for that chemically. But for general industry, we don't really see it as happening right now or in the foreseeable future. I don't know, did I miss anything that people are considering? Oh, you asked about lithium-ion batteries.
Yes.
They're getting cheap really fast. They're fantastic. Like their learning rate is so awesome. And they're still just too expensive. So what we see is that our capital cost is about 5 to 10 times cheaper than lithium-ion if you're trying to do lithium-ion batteries in an electric boiler. And so they're not cost effective yet for this industrial process heat space. And then also in that application, they're less efficient than like a thermal storage. So efficiency is not that big of a differentiator, but that the capital cost is the main thing there. But they have their place in system design for providing peaking and 4-hour and microgrid support and all of that. But we're not seeing them too much in the industrial process heat space directly.
Yeah, and your longevity of 30 to 40 years is significantly longer than a battery. Currently, the technology, anyhow, this time.
Yeah, I mean, we can do full depths of discharge, unlimited cycles. There's no degradation on cycling. And so that is a big differentiator against lithium ion still today. My understanding is that like the LFP and then some of the sodium ion batteries are getting better on that front. And so we're always keeping track of where they are. But right now we see that the thermal batteries just have this efficiency benefit, longevity benefit, and then, lithium ion, you're having to integrate other pieces of electrical equipment. And so there's a lot more balance of plant costs associated with it as well.
Jeremy, thanks for a great episode. To end this episode off, what is the biggest takeaway for our listeners?
The biggest takeaway, I think, is that, a lot of industry has this looming 2026 and 2030 decarbonization goals and mandates. And they've made big promises to stakeholders. And they've kind of picked all of the low-hanging fruit. And we see a lot of folks are really scrambling for, how do I deal with my scope 1 emissions, my process heat-based emissions? And the biggest takeaway I would say is that, Rondo and our heat batteries are here. We're commercially being deployed. We're a cost-effective solution. And we would really love to talk to you about your need and your application and your fit. And, we do wonderful feasibility assessments really quickly. And we can really, really quickly say, this location is going to be the easy low-hanging fruit for us to go after first. And then, for all of your facilities, here's kind of what the economics and the application look like. But really that scope 1 emissions are now within reach and can be cost effectively reduced.
Thanks for that, Jeremy. Dave, what's your biggest takeaway?
I'll just sort of summarize a little bit what Jeremy conveyed. Like, 86% of the world uses fossil fuels. I think if I heard Jeremy correctly saying like 26 or 30% is for heating load. That's scope 1 primarily. That is the area of focus that has to be Everyone looks at electrification. I'm not convinced we're going to be able to electrify cost effectively and as fast as what needs to be done. So if there's a solution like with Rondo and others that actually can help mitigate this fossil fuels for industrial heating, I think people are going to gravitate to it. They need to understand, as Jeremy suggests, be properly educated to understand what it is and how it fits. And that's a big part of we all have to do is educate the marketplace so they understand it. So I'll be really interested to follow and see how you guys are doing, because I think there's quite an interesting solution. And it's not new technology. This has been around for years. So I'm really looking forward to see how you continue with this, Jeremy.
Thank you.
Dave, Jeremy, thanks for a great episode.
Thanks so much, Jeremy. Appreciate it. Thank you, Lysandra.
Thanks for hosting me. Thank you.
That's all for today's episode of the 360 on Energy and Carbon podcast. Thanks for listening. Make sure to check us out on our website at 360energy.net and follow us on LinkedIn at 360 Energy Inc. Tune in to our podcast on Apple Music, Spotify, Anchor, or other listening platforms by searching the 360 on Energy and Carbon. You can watch the video recording and subscribe on YouTube at 360 Energy Inc. Email us your feedback at podcast@360energy.net or comment on our LinkedIn posts. See you next week.